1, 2b kind of applies them to some postulates a little more. So first thing you need to know is what is a postulate. And that's here. It is an accepted statement of fact. So you'll learn as we go that with theorems, they've needed to be proven, right? A postulate is just accepted as fact. So when you see postulate 1-1, we know it to be true, okay? So this is postulate 1-1, and please don't spend time memorizing postulate 1-1 as postulate 1-1. The only reason they name it 1-1 is it's chapter 1, and it's the first postulate we learned. 1-2 is chapter 1, the second postulate we learned. Don't memorize those, okay? What you need to do is you need to understand what it says. So this here is what I'm concerned with. This one says, through any blank points, there's exactly one line. Any guesses what number should go in that blank? How many points will always have exactly one line? 2, right. Through any 2 points, there's exactly one line. So in other words, if I were to put a point here, and I were to put a point here, there is only one line that I can put through those points, right? And that would be that line there. So through any 2 points, there's exactly one line. No more, no less. With that, we're going to start talking about intersections. And an intersection is really, you're looking for overlap. You're looking for where 2 things meet up. So the set of points that 2 or more figures have in common is their intersection. So for instance, postulate 1-2 talks about 2 distinct lines intersecting. So what it says is if 2 distinct lines intersect, they intersect in exactly blank point or points. So if you think about it, if I were to draw 2 distinct lines, in other words, 2 separate lines, not the same line over top of itself, right? So a line there and a line here. The question is, how many points do they intersect in? What do you think? It's 1, right? There is 1 point where they meet up, and there will only be 1 point where they meet up. So the intersection of 2 lines will always be 1 point. Okay. If you wanted to name it just to get some practice with how we write this stuff, this would be AB, this would be CD. If we called their intersection E, we would say that line AB, how do you write a line? What do you got to put? You got to put the line over top with the arrows, right? So AB, okay, that would be line AB and line CD. Oh, intersect. Man, my pen doesn't want to write for me right now. Intersect at point E. Okay. Questions so far? All right. Then postulate 1-3. And there's a really good picture. If you open your book, you don't need to do this now. You're welcome to do it now if you want. But in your book on page 30, if you feel like you need to see a moving picture of this, there's a really good picture of it where it shows the planes kind of rotating so you can see what you're supposed to see. But what it says is if 2 distinct planes, so 2 separate planes intersect, they intersect in exactly one what? Okay? So let's think about it this way. If I think of my floor as a plane, okay, so it keeps going in every direction, right? And then I think of this wall as a plane that keeps going in every direction. I want to know, what is their meetup? What, is it a point? Is it a line? Is it another plane? Where are they intersecting? What do you think? Yeah. A line, right. So their intersection is the corner that they meet at, right? So this line where they meet up, which just keeps going. So the intersection of any 2 planes will always be a line, okay? So that's this one here, and exactly one line. And I will draw you, real quick, a picture of what page, I can't jump around to page 30 because then I lose my recording. But if you want to take a look at it, you're welcome to. I will quickly just sketch you a picture of what it looks like in still version. So basically we're taking two planes and intersecting them. It's not awesome, but you get the idea. So let's say I have this red plane, I have the blue plane. What do the dotted lines mean? It's behind it. It's the hidden stuff. It's what you don't see, but it's there. So if I were to take 2 points, a point here and a point here, right? Those 2 points are on both of our planes. They're both on the red plane, they're both on the blue plane. So the intersection of those 2 planes is this line that's going to just keep going because the planes technically keep going, right? So whenever 2 planes meet, their intersection is a line. Okay? Questions on that? Okay, then we have this example. It's example 3. It's my first one I'm doing with you today, but the reason I write example 3 is it's 3 in the book. So if you want to refer to one similar to it, sometimes they're similar, sometimes they're the same, but it's like example 3 in the book.
Can you go back up for a second?
To there? You're welcome. First thing I want to show you real quick is just how to draw one of these if you ever want to sketch it in your homework, okay? There's a couple ways you can do it. I will show you the way I like, and then I'll show you one other way, and you can take your pick. But I understand if drawing a cube or a rectangular prism or something like that is a challenge, so I'm just going to show you some options. The way I like to do it is I start with whatever the front of my figure is. So if it's a cube, you start with a square. And then I like the dotted lines. So because I like the dotted lines, I do it so that from each corner, I draw a line that's longer than I want it to be. Kind of like at an angle backwards. But you need 3 of those that are identical. So this one, you want the same length and the same angle here, and the same length and the same angle here, and then you can just connect those, like that. Then to make it look more 3-dimensional, I do the dotted lines. So from this point, I'm going to do a dotted line parallel to this. From this point, I do a dotted line parallel to this, and then that same diagonal one that I did goes right here just as a dotted line. Okay, so that's one way you can do it. The other way you can do it that's probably a little bit easier, but you don't get the dotted lines as easily. You can draw a square. And if you draw that exact same square, just offset a little bit. So say I draw it here.
Seniors with the last name.
Okay,
A,
then all you have to do is connect your corners. So
with
here,
the last name
here,
A,
here,
E,
and there.
Coach
And then if you really want the dotted lines, you could go through and erase where you need to erase. So I could go like this. And you get the same thing. So if you are the type that likes to draw it and see it, you will have to draw it at some points because you're going to shade, but not always. Oh, you went and took a picture. All right. So here's what we're going to do. We're going to name the intersection of 2 planes. So first tell me, what is the intersection of 2 planes? A line, okay? So your answer should be a line, right? If they ask you to name that intersection, it should be a line. So if we look at these 2 planes, you have plane ADC. Can you tell me top, bottom, front, back, left, right? Can you tell me which plane is plane ADC? Yeah. ADC is the top. So here's A, D, and C. Those are all part of this plane. Okay? What's plane BFG? The right side. So that's this plane. So what they're saying is, where do they meet? What line do they meet at? line BC, right? Sorry, I kind of scribbled on my B there. But that would be this line where they meet. So your answer would be line BC. Do you see that? Hopefully. And if you don't, just let me know. We can work it out together. Okay, I'm going to take this out of there so we can scribble for the other one. The next one asks it a slightly different way. So now it's saying name the planes that have the intersection of line EF. So they're going to intersect here. Which two planes meet at that line?
A, B, and E, H, E, H, G.
What did you say for the first one? BAE. Okay, so your front face, right, this one here, has that line as part of it. So we could say plane. Here's the beautiful thing, by the way. Because they told you EF, you can use E and F as your plane. So you just need to add one letter to it, right? So we could say plane EF and then just add one on, so EFB. And we know that's going to intersect with, we're going to switch this, plane EF something. We just have to figure out what the third one is, okay? So if this is our line, what other face intersects with that line, top or bottom? The bottom. So that would be here, which would be EFG. Okay, could I call it EFGH? Are you allowed to use 4 letters to name a plane? You actually are. You can use 4 letters as long as all 4 are on that plane. You can use 5. You can use 10 if you want. You have to use at least 3. Okay, so you can do 3, you can do 4, whatever makes more sense to you. If I wanted to do 4 here, what would go with this one? EFB and A, right? So you could add A onto this one. If I wanted to do 4 here, it would be EFG and H. Okay, so up to you. If you like to do 4 because it makes that nice square, do 4. Okay? Yeah, right. No, 3 or 4, it's the same answer.
It doesn't matter what 3 you use.
It doesn't matter what 3 you use as long as they're on the plane that you're referring to. Yeah. Any other questions on that? Okay, I think that's the end of that page. So next page here, that's not what I wanted. That's what I wanted. One more postulate and then one more set of examples, and then we're good. Oh, one thing to note, when you're naming a plane, if you're going to use 4 letters, you need to go in order. So either clockwise or counterclockwise, you can't zigzag. Okay? So when you're naming it, we want to go like MLKJ, or you could go KLMJ. So clockwise or counterclockwise, but go in order. Okay? Okay, so postulate 1-4. Through any blank non-collinear points, there's exactly one plane. Anyone have a guess as to how many points you need to get exactly one plane, as long as they're non-collinear? What is non-collinear? Not on the same line. Okay, so if you have 3, 4, 5, what's our number of points you need not on the same line to get one plane? It's 3, right? Through any 3 non-collinear points, there's exactly one plane. Why non-collinear? What's wrong with these 3? 1, 2, 3. Is there one plane that goes through that? No, there's an infinite number, right? You can go this way, you can go this way, you can go all over the place with that. So 3 that are not on the same line will always get you one plane. Here's the beauty of this one. Any photographers in here? Okay, when you say, let's say you have a really nice camera, you're waiting for this cheetah to walk across the safari. Do cheetahs live in a safari area? Yeah. Anyway, so you're waiting for this like perfect shot, but you're waiting so long that you're starting to get a little shaky. What do you do with the camera? You put it on you stabilize it on a what? A tripod. A tripod, right? Not a quad pod. A tripod. Why a tripod? Because any 3 points are always going to rest on one plane. So a tripod cannot wobble. It can't. As long as you have the legs properly set, it won't wobble. Maybe you've sat on a 4-legged stool before. Does it wobble? Sometimes, right? Mine wobbles a little. It's pretty good. Not bad. But a 3-legged stool, I don't know why they don't just make them all 3-legged. Maybe it just isn't as, like, you don't feel as sturdy. But a 3-legged stool doesn't wobble. Now, don't get me wrong. If you had a 3-legged stool and your one leg was this long and the other 2 were the full length, your stool's not going to sit right? You're going to sit at a very sharp angle, but all 3 legs could touch the ground, okay? So through any 3 points, there will always be a plane. Something I tell students to try is take your 1, 2, 3, your pointer, middle, and ring finger, and see if you can get them all to rest on your desk with straight fingers. Don't bend them. They should rest on your desk, right? Okay, now add your pinky and try and get all 4 to rest on your desk with straight fingers. Doesn't necessarily happen, right? If I put my pinky down, my middle finger comes up. Maybe some of you have just crazy length fingers and you can make it work. But so through any 3, you'll always get a plane. With 4, not necessarily. Okay, so with that in mind, here's what we're going to do. We're going to shade the plane. Okay, we're going to shade these. Shade the plane that contains these different points, okay? So if I said what plane contains points N, P, and Q? So if you look where N is, where P is, and where Q is, can you tell me top, bottom, left, right, front, back, or some diagonal, is there a face that has all 3 of those? The bottom, right? So the plane that contains those, and if you feel better about it, you can tack the R on there because R would be part of that plane. But what you need to do is just shade that bottom plane. Okay, so that's our blue shading, is that one. What plane has J, M, and Q? It's a little trickier, right? So here's J, here's M, here's Q. Can you tell me a 4th point that seems like it should go with them? Yeah, P. Okay, here's the thing. That plane is not drawn in for us, right? But there's planes all over the place. So even though it's not drawn in, it doesn't mean it's not there. You can think of it kind of like my Kleenex box. Okay, we have J and M are here and here, right? Q is back here. So this would be the other point that corresponds to it. It's like we're cutting the diagonal through my Kleenex box. That would be our plane. So what you need to do for that one, because the line's not drawn in, I would put a point at P, just because that's the point that corresponds. And then you need to draw in the lines that aren't there. So this line's already there. This line is not. This line's already there. So the plane is this kind of diagonal through here. Okay, so that's our red for that one. Do you see that? Okay, last one then. M, L, and Q. Top, bottom, front, back, left, right. What do you see? Bryce.
K on the back.
Right, if we add, not K though, R.
I thought that was.
Yeah, no, it's an R. You can't really tell. Here, let me help. There we go. So if you take that back face, right, you have M, L, Q. We'd add R to it. That would be the back face. Okay. Any questions on that? Okay. Try to get comfortable drawing some of those cubes and rectangular prisms because you are going to do a little bit of shading with them today where you're going to have to draw the figure. So give it your best shot. I'm not going to freak out if it doesn't look perfectly cubular. Does that make sense? But give it your best shot. See what you can do. You'll get real used to it as the year goes on. You'll draw a lot more of that stuff. So that